Right, let's begin. We're starting with the Perlis question 2023. Okay, diagram 6.1 and 6.2 show the ray diagram of a tree position at two different distances. Okay, once again, everybody, remember that when we're at question 6, we're expecting, uh, compare and relate question. Okay, so that is our main question. All right, so what is the characteristic of the image formed in 6.1? Okay, since this is a mirror, okay, and it is on the same side as this one, okay, this will be a real image. Okay, um, remember that for mirror, okay, if it is a mirror, if the object is here and the image is here, this image is real. But if it is a lens, okay, if this is the object and the image is on the other side of the lens, this is a real image. Okay, so the position of the image tells us whether the image is real or virtual lah. Okay, tapi remember that mirror and lens are both different in terms of their function lah. Mirror dia punya tujuan adalah untuk reflect. So kalau dia pantul balik, dia mesti pantul balik ke tempat yang sama, so that it becomes real lah. Whereas lens, the idea is to refract. So dia mesti keluar daripada lens, not kembali. Kalau dia kembali, is virtual. So because it's not doing its job. Okay, lens is supposed to refract light lah. So if the object is on one side, selepas dia melalui lens tersebut, you form the image on the other side of the lens, that image becomes a real image. Okay, just to bear in mind lah. Oh, and also by definition, remember that a real image definition okay, is an image that can be captured. Okay, that can be captured on a screen. By definition okay, a real image is an image that can be captured on a screen. The most difficult thing to imagine actually is the mirror. Okay, because every time we see a mirror, we think that, oh, okay, the picture inside there is a real, dia di dalam cermin lah. So we think that that's a real image. But in actual fact, if you have a mirror and you put a screen in front of the mirror, okay, let's say you have a mirror over here and you have a screen over here, right? So let's say you put an object over here. If you can capture the image of the object, okay, on the screen, whether it's behind the object or is in front of the mirror lah, okay, that image is a real image. Okay, so yeah, so that's by definition lah. Okay, a real image is an image that can be captured on the screen, whether it is a lens or whether it is a mirror. Okay, the definition remains the same. All right, observe 6.1, 6.2, compare the object distance. Okay, as you can see quite clearly over here, 6.1 is bigger than 6.2. Okay, in terms of the image distance, the image of 6.2 is much further. Okay, dia punya jarak di sini lebih jauh. So 6.1 is smaller than 6.2. The size of the image, you can even see it here. This is the image for 6.1. This is the image for 6.2. So 6.1 is less than 6.2. Okay, based on the answer, state the relationship between the object distance and the image distance. Okay, so we are doing a relationship between these two things. And since they are both in different directions, okay, one, but of course 6.1 dua-dua di depan lah. Okay, so that means one bigger, one smaller. Okay, so the bigger the object distance, the smaller the image distance. Okay, and likewise, state the relationship between the object distance and the size of the image. Okay, object distance and size of the image. Object distance is this. Okay, size of the image is this. Since they are both also different directions, so they will have the same this one lah. The bigger the object distance, okay, the smaller the size of image. Okay, so this is quite an easy comparison lah, I feel. Okay, good starting for our very early morning class. Okay, diagram 6.3 shows a parabolic dish used to receive signals from a television station. Okay, we see this Not just parabolic dish, this is the standard one. This is the one that we see for astro. Even satellite dish also, this is also uh, same application. Okay, so the question is, where is the receiver placed to obtain the strongest signal? Okay, so that means this receiver, you can adjust it, no? Kau boleh jadi dia lebih panjang ke, atau lebih pendek ke, atau ke atas ke, atau ke bawah. Okay, but the ideal answer for this would be at the focal point of the and then depends on the alat yang kamu pakai lah. In our case here is a parabolic dish, so you write parabolic dish lah. Okay, the idea is this: to obtain the strongest signal, you need to put it at the focal point of the parabolic dish. Okay, so the reason for this, oh, sorry, the reason for this, even according to the black book lah, okay, it is the same, but let me just, according to the black book, oh, okay, so the reason for this will be all the signals, okay, all received signals can be focused on one point. Okay, actually, another possible one which is probably not this one, is more signals okay, more signals can be received. The idea again, everybody, is to make sure that you don't write this as the reason. Okay, because that is actually one reason, so that you can obtain the strongest signal. Okay, so if that is already given in the question, of course you cannot write this as a reason lah. Okay, you have to think of a different reason. So one of the all received signals can be focused on one point, so you don't get all these stray signals and pergi ke tempat lain. Secondly, you can receive more signals or stronger signal but the problem is stronger signal is already in the question, so we cannot use that one. Okay, so these are two alternative answers. But this is pretty much the same answer for situations like parabolic dish, satellite dish, mirror. Okay, so you kind of want to have that kind of this one, position of the object, the position of the receiver, okay, should be at the focal point. Okay, not higher, not lower. Yeah, so this is a specific kind of answer. All right, let's move on to Kelantan. Okay, Kelantan 2023. Okay, take note that this is question number 11. This is a section C question. So Kelantan 2023's question this year is maybe an important one for us. Okay, because it's it's an essay question lah. Okay, so diagram 11.1, 11.2 show a light ray, etc., etc. Okay, what is the meaning of refractive index? The meaning of refractive index is the ratio. Okay, the ratio of the speed of light in the air, in the vacuum, in the air lah. Okay, or vacuum to the speed of light in a medium. Okay, the ratio of speed of light in the air to the speed of light in the medium. This is the official or the standard definition lah. Okay. As a side note, okay, remember that the formula for refractive index, there are three formulas now. Okay, number one, the standard one is sine I over sine R. The second one is the speed of light, okay, in the air over the speed of light in the material, in the medium lah. Okay, the good news is the speed of light in the air in the medium will be given to you lah. Okay, the third one is the real depth over the apparent depth. Okay, real depth over apparent depth. Dalam nyata dan dalam ketara. And finally is 1 over sine C. Okay, where C is the critical angle. Okay, another important point to note when you're talking about refractive index is that all values of refractive index must be more than 1, because the refractive index of air is 1, and air is the the least dense material, at least on Earth. Okay, so which means that when you're using sine I over sine R, this is a common one now. When you're using sine I over sine R, don't take it literally as the incident angle and refractive angle. Okay, always put the bigger angle on top. The bigger angle, the bigger number, the bigger angle always goes on top. Always. Okay, always on the top. Okay, don't limit yourself to, oh, this is the incident angle, because that's where the light is going in. Don't. Okay, so 11.1, 11.2, compare the incident angle, refracted angle, speed of light. Okay, 1, 2, 3. Okay, hence state the relationship between the speed of light in X and Y with the refracted angle to make a relationship between the refractive index and the optical density. Okay, there's a lot of stuff going on here. Okay, so let's take a look. Incident angle. Okay, since both are at 40 degrees. Okay, so in terms of the incident angle, 11.1 is equals to 11.2 because they're the same one lah. Okay, refractive angle. Kalau refractive angle kita lihat 125, the other one is 15. So in terms of the refracted angle, 11.1 is bigger than 11.2. 11.1 bigger, right? Yeah. Okay, then 11.2. Okay, the speed of light in material X and Y. Okay, so this is the important thing lah. Okay, is not given. Oh, it is. Sorry. Okay, speed of light. This is X 1.9737, and this is Y 12097. Okay, so you can see that it is also the same thing. Speed of light is 11.1 bigger than 11.2. Okay, so state the relationship between the speed of light with the refracted angle. Okay, that means dia mau kamu relate this one and this one. And since they are both the same direction, okay, so we can say that the bigger the speed, the bigger the refracted angle. Okay, and the last relationship is refractive index, okay, with the optical density of the material. Okay, this is the refractive index, tiba-tiba the optical density kan. Okay, but generally, okay, this is a kind of a factual thing lah. Okay, the bigger the refractive index, the bigger the optical density, okay, of the material. But okay, it should be the other way around. Okay, it should be the bigger the optical density. Okay, baru the bigger the refractive index. Okay, the refractive index is the ability to bend the light lah. Okay, optical density is sedia ada, so that's why optical density should come first, and then refractive index at the back. Okay, so the bigger your optical density, not density. The bigger your optical density, the bigger the refractive index. Dia lebih upaya untuk membengkokkan cahaya. Okay, nearer to the normal. Okay, 11.3 shows an incomplete ray diagram. Okay, so you have the air and then you put that Y and the X on top of each other lah. Okay, so explain how light rays travel through material Y and material X and complete the ray diagrams for both substances. Okay, so one thing to think about lah, and I would like to give you this tips lah. Okay, if let's say a question this year asks about refraction, and usually they ask you how the light travels after refraction lah. Okay, so I think it's a good idea to keep these tips in mind. Hold on, let me see whether I put it in the next. Oh yeah, this one. Okay, this is I think a good this one, so that it kind of helps you to focus on okay what you need to say. Okay, the question is asking, okay, how the light rays travel through material Y and material X. Okay, so first they masuk Y and then they X, and then they ask you to complete the diagram. So I suppose material Y is 1 mark, material X is 1 mark, and then complete the ray diagram is 2 marks now. Okay, so the idea is this, when you want to talk about how light rays travel in refraction, in cases of refraction, think of these 2 points. First, you tell me where the light travels from. Okay, is it from less dense to more dense or more dense to less dense? And then secondly, you tell me the direction of refraction from the normal line. Okay, is it going nearer or further from, not away lah, or further lah. Okay, further also can. Okay, further or away from the normal line. So you can, so this helps us to, okay, saya tidak payah cakap banyak, betul. Okay, refraction, kau bagi tahu saja, dia pergi dari mana ke mana, dan kedua, okay, bila dia pergi dari sini ke sini tu, is it going to go away or nearer? Okay, so in the case of the red color, it's going from less dense to more dense. Okay, so because it's going from less dense to more dense, it will refract nearer to the normal line. And then in the case of the green color, if the light is moving from a more to a less dense, okay, then it's going away from the normal line or further from the normal line lah. Okay, so which means that dia punya angle kan, kalau nearer to normal line, dia punya angle mesti kecil. Kalau dia punya away from the normal line, the angle must be much bigger. Okay, so have this in mind so that if let's say the question keluarkan that they ask you to explain, think of these 2 points enough. Okay, where is it traveling to? And kalau dia travel kan, macam mana dia punya refraction direction? Away or nearer to the normal line? Okay, so this is the important key lah. Okay, so in the case of this one, let's think about this first situation first. Okay, the first situation over here, okay, is going from air to Y. Astaga. It is going from air to Y. Air is the smallest density lah. Okay, optically dense, there is a optical density, air is the smallest. So you know that it's going from less to more. Okay, so this is less, this is more. Okay, in the case of the first part, okay, from going into material Y. So according to this, less to more means it's going to go nearer to the normal line. Okay, less to more, therefore nearer to normal line. Okay, then secondly, kita mau tengok dia pergi dari Y to X. Okay, when it is traveling from Y to X. Okay, so we have to consider the situation. Okay, refractive index of X is 1.52, refractive index of Y is 2.48. So Y obviously is very dense compared to X because dia punya refractive index adalah kecil. Remember that this one you said just now, the bigger the optical density, the bigger the refractive index. Okay, and since X has a smaller refractive index than Y, means in this situation, okay, in the second situation, it is going from a more dense to a less dense situation because not as less dense as air, but it's still less dense than Y. And how you know this is from the refractive index. The number tells you. Okay, so that's why this number is very important, this refractive index. Oh, 1.52 means less dense dari 2.48. And the good news is, dia ikut dia punya nombor lah, 2.48 lebih besar daripada 1.52. So that means 2.48 itu lebih tumpat. Okay, more optically dense than X. And so, since it's going from more to less, okay, take a look at this. More to less means it's going to go further from the normal line or away from the normal line. Okay, away from the normal line. Okay, so when you have that in mind, then you know how to write. Okay, the red color that I wrote over there is point number 1. The green color I write over there is point number 2. Okay, so yeah, I know how do we write it in proper sentence. Okay, point number 1, red color. Okay, have this in mind. Point number 1 is less to more, so it's going to go nearer to the normal line. Okay, so the ray of light travels from a less optically dense to a more optically dense material. So it refracts. Okay, so it refracts nearer, okay, to the normal line. So semua point ada di sana. Okay, dia pergi dari mana ke mana, and then lepas itu dia punya pergerakan itu mendekati atau menjauhi. So you have all this in one point. Okay. Second is a green color one. Okay, green color one is going from more to less, so it's going to go away, okay, from the normal line. So the same sentence. Okay, so the ray of light travels from a more optically dense to a less optically dense material. So it refracts, okay, away from the normal line. Okay. Okay, right now, because our class is so diverse, got different kinds of people with different levels. Okay, so I'm giving you the main template first. Okay, I'm giving you the main template so it helps you to study this better. Okay, so you know that, okay, kalau dia tanya pasal refraction, saya tahu sudah, okay, ini jawapan mesti ada sedia. Because you cannot run away. If the question this year comes out from refraction, you definitely cannot run away from this explanation. You have to explain the movement of light. The movement of light when it goes from one density to another density. Ini mesti. Okay, so I'm just helping you to kind of summarize this so it makes it easier. But if you are able to, okay, I would suggest actually that you write in the material itself. Okay, a ray of light travels from a less optically dense, okay, air, and then to a more optically dense material, which is material Y. Okay, then in the green color, ray of light travels from a more optically dense, okay, material Y, okay, to a less optically dense material. This is material X. Okay, I don't think it's necessary. Okay, the yang perkataan dalam warna biru, I don't think it's necessary because kalau kamu tulis saja yang merah dan yang hijau, kau sudah memenuhi syarat. You've already met the requirements for what you need to write lah. Okay, but I'm talking to the people that, you know, you want to give your answer, kind of answer. So, you know, write in the kind of material lah. Okay, whether it's air or Y. It really shows that you have the understanding that you need. Okay, now when you have this in mind, then you can draw. Okay, okay, remember, this 30 is not the incident angle. The incident angle is this, okay, it's 60. Okay, all I need to know is, oh, sorry, do we calculate the refracted angle since we know the refractive index? You don't have to lah, because it is not given in the question. But I guess if you have extra time, why not? Okay, you don't have to. Okay, but all you need to know is, all you need to show, okay, all you need to show is that when it travels from air into material Y, it has to be a smaller angle than 60. Okay, that's the most important thing. Okay, this angle must be bigger than this angle. Okay, itu saja. We just need to see that, because I mean, it's not telling you to draw it according to scale. So, you know, just complete the ray like that. Okay, then after that, draw a normal line over here. Okay, you can cinca draw, but of course draw using a straight line, using a ruler. Okay, and then since this is going to go away from the normal, so yang paling penting, okay, yang paling penting adalah yang sudut ini must be smaller than this angle. Okay, the yellow must be bigger than the pink, and the purple or whatever color this is lah. Okay, the purple must be bigger than the green. Itu saja. That's all we need to see. Okay, paling pun letaklah ada anak panah gitu. Okay, and you're good to go. This is 2 marks. Okay, but it comes from the understanding of this refraction thing lah. Okay, so I highly recommend that you keep these tips on how to write the refraction, okay, in mind. Okay, 2 points only. Okay, kalau dia pergi dari sini ke sini macam mana? Kalau dia pergi dari situ ke situ macam mana? Okay, so that it helps you to focus your answer so you don't go all over the place lah. Okay, so that is the explanation for this. Gosh, I spent so long on this part. Sorry. Yeah, hold on. Okay. Oh no, no. All right, let's move on. All right. Diagram 11.4 shows an endoscope used to study the blood cells tissue in medicine. Okay, this is endoscopy. Then you put it lah. Okay, you kasih masukkan dalam. Okay, either in the mouth or either through the mouth or through the nose lah. Okay, and then after that, there's all this. So there's a protective jacket, there's an outer cladding, and then there's an inner core. Okay, over here, this is the inner core. Okay, and this is an example of a fiber optic. So when the signal is sent through the fibers, it is found that the resulting image is less clear. You're required to invent an optical fiber that can transmit signals more efficiently. Take note of this. You cannot write this in your answer, and produce clearer images. Okay, remember that in the question, you cannot repeat it as the answer as much as possible. Actually, not even as much as possible. Okay, so be aware of the answers that you cannot use. Okay, stay explain the design based on the characteristics of the material of the inner core, the purity of the material, the flexibility of the material, and the type of protective jacket. Okay, again, there are 4 characteristics given. You need to find 5 because this is question number 11. And so what I've done is I am going to put 2 points for the characteristics of material, point 1 and point 2. Point number 3 is the purity of the material. Point number 4 is the flexibility. And point number 5 is the type of protective jacket. Sebab point 3, 4 and 5 tidak boleh lari jauh. Like purity is either high purity or low purity. You cannot give more than one answer. Flexibility is high flexibility, low flexibility. Itu saja. And then the type of protective jacket, dia minta type. So you cannot talk about the characteristics of the protective jacket. So that means you have to talk more about the characteristics. Okay, now the answer for this can mainly be found in page 54 on the black book lah. Okay, you can actually find this over here. I'm just going to skim through this lah. Okay, if you have your black book, you can take it down. If not, then you just jot down lah. Okay, muka surat 54 lah. Okay, if you have the black book, it's in page 54. Okay, okay, I want to start with point number 3 first lah. Okay, let me talk about the characteristics in a while. Okay, point number 3. You want high purity, and the general answer for this is to minimize energy loss. Okay, high purity is to minimize energy loss. And then the 4th point, the the 5th point. Okay, oh, you know what? Let me talk about the 4th point. Okay, 4th point is here. Okay, high flexibility so that you can easily bend at the curved parts. You want the thing, let's say it goes inside your nose lah, through your nose you want the optical fiber to be able to bend its way lah. Kalau dia lurus dan keras betul bahkan macam mana kau mau kasih cucuk masuk di dalam badan kamu. So it has to be very flexible. Okay, so that it doesn't hurt your body lah. But the general answer is it can easily bend at the curved part. Okay, your esophagus lah, your wherever it is yang curvy lah, boleh tu. Okay, so the 3rd point is the purity, the 4th point is the flexibility, and the 5th point is the protective jacket. Okay, generally we use rubber, okay, as a protective jacket. Okay, and the reason is so that you protect the internal organs. We don't use a glass. The outside of the fiber optic is not glass lah. Kalau dia pecahkan habis kau punya badan. Okay, so we use rubber as a protective jacket, not plastic, because plastic also can break. Okay, rubber is more malleable lah. Okay, so it can protect the internal organs. Okay, let's talk about the characteristics. Unfortunately, not really unfortunate lah, but in our black book, there's only one possible answer for this one. Okay, now this is the first time I'm seeing a question like this lah, that they ask for the characteristics of the inner core only, Okay, Okay, they are asking for the characteristics of the material of the inner core. Okay, most questions involving fiber optics will ask you for the refractive index of the outer layer and the refractive index of the inner layer, because our fiber optics, okay, if you can if you see over here, so there's an outer layer over here, okay, and then the core is the inner layer lah. Okay, so both of these two have their own kind of refractive index. Okay, and the black book's answer generally, which I recommend you to memorize also, is that the refractive index of the outer layer is less than the refractive index of the inner layer. Okay, and the reason is so that total internal reflection can occur. But since this question is only asking for the inner layer, so I'm going to adjust the answer a little bit. Okay, so all we need to just say is that the inner layer the inner core punya refractive index must be big, which is still the same answer as the one in the black book lah. Okay, cuma black book dia cakap outer layer less than the inner layer. Okay, but in this one we say that the inner layer is big refractive index. Okay, and the reasons, two possible reasons for this is, if you have a big refractive index, you have a small critical angle. Small critical angle means you can, total internal reflection can occur. Okay, so this would be my first point for the characteristics of the material of the inner core. I'm just changing the answer a little bit from the black book. Okay, and you can jot this down to write this now. Okay, other possible answers for this one would be this. Okay, for the characteristics lah. You only have to give two, but you can give all three if you want. Okay, so the first one was the high refractive index. Okay, the second one is high optical density. Sorry, my bad. This should be high optical density. High optical density means high refractive index. High refractive index means small critical angle means total internal reflection can occur. That is the order in which you should think of things. Dia punya optical density besar, refractive index besar. Refractive index besar, small critical angle. Small critical angle means very easy for total internal reflection to occur. Okay, and then the third possible answer is you have a small critical angle. Okay, small critical angle means total internal reflection can occur easily. So all these are characteristics. Okay, characteristics of the material of the inner core. Okay, so I've given you three. Okay, you have to write a minimum of two. Okay, you can write more if you want, but well, I guess two is enough. Okay, so sorry, I know it. Actually, even I feel I know that we're kind of rushing this, but you know, don't worry, just take screenshots and then you just copy this down later, okay, as much as you can copy. Okay, but if can't, you can always wait for the video to come out and then, you know, jot this down. But of course, there are certain things which I feel that if you join the class live, there's definitely a slight advantage, because, you know, well, I like to believe there's an advantage. Okay, let's move on to Melaka. Okay, Melaka 2023. Okay, this is question number 2, which should not be a very big mark, but remember, question 1, 2, 3, 4 is knowledge questions. So there may be calculations, there may be drawings, so be aware of this. Okay, diagram 2.1 shows the image form on the side mirror of the vehicle. State the curved mirror. Okay, this is definitely convex mirror. Okay, convex mirror, remember, convex mirror is C more. Okay, manakala concave mirror is C bigger. So, convex mirror, standard answer for convex mirror is always wide range of vision or wide range of view. Okay. If you want, well, the marking scheme is an alternative answer. Okay, image form. Oh no, what is my handwriting? Image formed is upright and diminish. Okay, also a possible one, but our standard one usually, okay, is always wide range of vision. Okay, easiest to remember. Convex mirror, wide range of vision. Wide range of vision means you see more, but everything is smaller. Okay, all right. Just to remind you, convex mirror, this is how you would draw the mirror. Okay, it is curved outwards. I just saw a convex mirror yesterday. I was passing by you know, the mirror yang keluar itu kan. I was looking at it from the side. Betul-betul dia keluar. Okay, anyway. So determine the image. Okay, this is, I think, not a problem, but the reason why there is a dotted line over here is to tell you where to stop drawing lah. Okay, the thing that you should not be doing, especially kalau soalan itu keluar begini bahkan, okay, is that you draw the line untuk menyentuh itu mirror. Okay, actually it doesn't. It only hits technically lah. Okay, technically it only hits the principal axis. Okay, which is this dotted line over here. So dia mesti kena sini dan cukup sudah. Okay, so the first line, I wish I had a ruler for this, but never mind. The first line is from the object over here, draw a straight line. Okay, and then after that, it's supposed to mencapah keluar lah. Okay, but whatever it is, draw a dotted line from here all the way to F. Oh dear, so ugly. Hold on. I cannot accept this drawing. Okay, dotted line to F. Yeah, something like that. Okay, and then continue the dotted line to go outwards like this. So dia ke sini dan keluar. But it must start from the focal point at the back. Okay, and then the place over here where it intersects, okay, this is where the image is formed. Okay, and then mark this down as image. Okay, the place of intersection is where the image is formed. Okay, this is a 2-mark question lah. So 1 mark for the blue color and 1 mark for the image. Okay, the blue color is the difficult part lah, because you have to remember that convex mirror dia adalah keluar, bukan ke masuk. Okay, what is ke masuk? Sorry. Yeah, it's supposed to, you know, diverge, not converge. Okay, so ini adalah the ray diagram. Oh, is that it? Oh, there's supposed to be another question over here, but never mind lah. Okay, let me give you this one. I'm pretty sure that the question that is missing is state the characteristics of the image now. Okay, state the characteristic. State 1 lah, because it's only 1 mark. Because this is 2, 3, 4. Yeah, it should be a 5 mark. Okay, state 1 characteristic of the image form. Okay, 1 mark. So this one is, okay, convex mirror, people. Convex mirror, like concave lens, has the same set of characteristics. It is always virtual, upright, or diminished. Okay, all you have to do is just mention one. Convex mirror, concave lens. Okay, these two have the same set. Yang rinse, rim, boom, itu bahkan itu adalah convex lens and concave mirror. Itu different story. Okay, convex mirror is always VUD, virtual, upright, diminished. Okay, concave lens is also VUD. Okay, virtual, upright, diminished. Okay, so remember this always. Okay, asal convex mirror, wide range of vision. Asal convex mirror, VUD. Okay, and the same way also for concave lens. Okay, because of the fact that it is a diverging material. Oh, sorry, it's a diverging thingy lah. Okay, diverging mirror, diverging lens. Okay, very important. All right, let's move on to Negeri Sembilan. Okay, Negeri Sembilan. Aha, mirror again. Okay, see the center of curvature of the mirror. Okay, one mean, I don't know whether this will be important, but I think it will be. But never mind, we'll talk about this later. Okay, state the light phenomenon. People, if it is mirror, okay, mirror is always reflection. okay, of light. Okay, as a side note, remember that kalau dia adalah lens, then it is refraction. Okay, if it is mirror, it's reflection of light. If it is lens, it is refraction of light. Okay, calculate the focal length for the mirror. Okay, this is a very important thing to understand now. Okay, there is a relationship over here. Okay, where C, the value of C, the length of C is always 2 times of the focal length. Okay, so kalau daripada pusat cermin sampai ke C is 30 cm, then you know that F is 15 cm. Okay, because it's 2 times of the focal length. So, this one is really nothing. There's only one mark lah. Okay, 30 divided by 2, which is 15 cm. Okay, you actually don't have to calculate lah, but just make sure you give your answer with the unit. Okay, no unit, remember, no mark. Okay, complete the another drawing diagram. Okay, this is the same thing. It's the same thing as the one that we drew just now. Okay, it's the same thing that we drew just now, except that, and yeah, even the center line has been given to you. It's the exact same drawing. Okay, it's the exact same drawing. I'm not going to draw this for you. I want you to try it yourself, but it's the exact same drawing as the Melaka paper. Okay, so tolong cuba sendiri. We definitely know that the image must be formed somewhere here. Okay, image tu mesti terbentuk di dalam sini because it's virtual upright diminished. Okay, which is the next question. Definitely that there. State one characteristic of the image. How boring is this? Okay, virtual or upright or diminished. Okay, this is a convex mirror. Okay, dia tidak tulis lah, but this is a convex mirror. Kalau concave mirror, macam mana bentuknya? Dia bentuk ke dalam, macam tu. Okay, this is a concave mirror. Kalau concave mirror, kalau objek kita di sini, it will focus on the F. Okay, dia ke sini. Okay, kalau dia convex mirror, dia akan keluar. Okay, kalau concave mirror, ini adalah concave. Okay, concave mirror, dia akan fokus ke dalam. But this is convex mirror. Okay, so knowing the difference now. All right, let's continue. So a shopkeeper, this is your trial exam question. Okay, a shopkeeper plans to place a mirror at location Y to help him monitor the safety of the shop. Wow. Okay, so state the characteristics of the mirror. Definitely the type of mirror we know is a convex mirror lah. Okay, and the reason, standard reason, okay, why wider or wide, okay, field of view. Okay, standard answer lah, okay, for this one. Very physics answer, so don't worry about, this general answer. No, it's just physics answer. Good. Field of view is a physics concept, apparently. Okay, the diameter of mirror, okay, diameter of mirror must be big. Okay, big size mirror lah. Kan? What's the point of having a convex mirror? Kan? Kalau dia sekecil begini saja, big mirror lah. Okay, and in order for you to have a big mirror, you can give the standard answer. Okay, wider field of view. Wider field of view is a more sophisticated answer, but it actually just means that you can see more. Okay, you can see more of the shop. Okay, but we just give it a nice sounding answer by calling it wide field of view. Okay, which you can totally forget after this. Okay, kau boleh lupakan lah selepas SPM kalau kau mau. But wide field of view is this one. Can give the same reason for both questions? Yes, because it is relevant. Definitely can. Don't worry about giving the same reason. But if you are but don't give it if it is irrelevant. Like you cannot say if you want to talk about the brightness of the mirror lah, contohnya lah, okay, contohnya you want to talk about the brightness of the mirror, then your answer will be brighter mirror lah, so that then you cannot give the reason wide field of view. Apa kaitan wide field of view with brightness of mirror? Got no kaitan lah. If it is a relevant reason, you can repeat the reason. Totally not a problem. Can. Even in section B, section C. Okay, just make sure that your reason is relevant to the characteristic. You can give the same reason, no problem. Thank you for the question. It's a good question. Okay. Just a side note, when we say diameter of mirror is big, okay, our general reason is wide field of view. But if it is lens, diameter of lens is big. Lens is kanta. Okay, diameter of kanta is big. Okay, the reason is not wide field of view. Wide field of view is mirror. Okay, the reason for the diameter, a big diameter of lens is so that more light, okay, can enter. Okay, and it depends on what is your object lah. Kalau dia camera, bahkan bigger lens means more light can enter. Like if you have a tiny lens, like our smartphone lens, okay, very little light can enter. Okay, but generally a big size lens means more light can enter, and when you have more light can enter, you can produce a better image lah, a sharper image, a brighter image. Not sharper, brighter image lah, clearer image. Okay, but the general answer for diameter of lens big is more light can enter. And the reason why I'm writing this note is because mirror and the lens, kita mau cakap big lens, big mirror. Tapi kalau big mirror, the reason is wide field of view. Kalau big lens, the reason is more light can enter. Okay, so remember this as, two different things lah. Okay, diagram 9.1 shows a mirror, a woman applying makeup in front of a curved mirror. Okay, with her image formed in the mirror. Okay, so this one is makeup mirror. Makeup mirror is not the same as the side mirror, not the same as the shopkeeper mirror. Shopkeeper mirror is convex mirror. Okay, you want to see more. But in this case, look at our lady's eyes, super huge. Okay, you want to see bigger. You want to see bigger means you're looking at a concave mirror. Okay, in this case, okay, it's a concave mirror. Okay, so concave mirror is not wide field of vision. Concave mirror is to be able to magnify the image. So, state the light phenomenon involved. Of course, the light phenomenon involved will be reflection. Okay, sebab dia melibatkan mirror. Hold on. Okay, now, based on diagram 9.1, okay, and this is everybody's problem, okay, when it comes to talking about how the image is formed. Okay, so I want to introduce to you, I guess a shortcut lah. Okay, we call it the Woody shortcut, or I call it the Woody shortcut. I should patent this lah. Okay, so you want to have 4 points, and you want to talk about how the image is formed. Okay, on a lens or on a mirror. I think you can use this, for both lens and mirror. Sorry, this should be mirror. Okay, but or lens, doesn't matter lah. Okay, so to help you, you can use the Woody method lah, WODI. Okay, the first point is talk about what mirror or what lens you're using. Second point is where is the object. Okay, is the object near less than the focal length, or less than the focal length, or more than the focal length. Generally, these two places lah. Okay, the third one is draw a diagram. Okay, and then the fourth one is talk about the characteristics of the image. Okay, I know. This what is this so cholo one? Image what? Okay, just characteristics of the image lah. Because I wanted to, I wanted to WODI lah, so it's easy to remember. Okay, so W for what lens, O is for where is the object? Okay, object di mana. D is for the diagram. You have to draw the diagram. Okay, in this case, and the fourth one is what is the image characteristic. Okay, what lens, object, diagram, image, what. Okay, and if you have this, then I think you can give a very comprehensive explanation for this point. Okay, so how a magnified image of the woman is formed by the curved mirror. So the first one you have to talk about is what kind of mirror we're using. Okay, so the first point is use what is the mirror? Concave mirror. Okay, that's the first point. What mirror you're using. The second point is the object. If you're talking about magnifying, okay, actually this is quite easy lah. The object has to be less than the focal length. Okay, object or woman okay, is placed at a distance that is less than the focal length of the mirror. Okay. Again, generally, I think there are only two positions. I don't think they will ask you for very far. It's either less than the focal length or more than the focal length. Okay. If you can remember all the five, especially for concave mirror lah. Okay, if you can remember all the five, then very good lah. Okay, but generally it's less than the focal length or more than the focal length. Okay, but in this case it's less because you want it to be magnified. Remember that the five characteristics is read, ris, rim, voom, voom. Okay, so anything less than the focal length is voom. Anything more than the focal length is this tree. Read this, read. Okay, so you want it to be virtual because it's in the mirror. You want it to be upright. You don't need it to be terbalik. So there's only possible one is boom. Okay, and it should be less than the focal length. Okay, number 3 is the diagram. I'm going to talk about the diagram in a little while, but let me go to point number 4. The image form is, and you know, since you remember VOOM already, write all 3. Don't write just one. Okay, virtual, upright, and magnified. Okay, so hopefully using this Woody method, okay, will help you to, kind of focus your explanation lah. Okay, think about the 4 points. Okay, what is the lens using? Where do you put the object? Third one is draw the diagram, and then the fourth one is tell me the characteristics of the image. Okay, and the diagram, obviously, okay, so this is the part where most people, if you cannot handle the diagram, then don't worry about it. At least you got 3 marks out of the 4. Okay, just definitely lebih baik daripada langsung tiada markah. Okay, so in terms of the diagram, this is how I would draw this. Okay, this is a concave mirror. Ouch. Okay, this is a concave mirror. You put the object less than the lens. Okay, over here. And then the first line is here, all the way to the axis, and then to the F. Sorry. So ugly. Sorry. Okay, and then the second one is to the center of the image. Oh, sorry. Actually, there should be another F over here. 2F. Okay. 2F or C lah, depending on whether you want to put it as C or F. Okay, so the second one is, use a different color. Okay, the second one is draw a straight line from here to the 2F. Oh no. Okay, all the way until here. Okay, we totally inverted lah. Okay, and somewhere along the way, hopefully it meets lah. Okay, you extend the line. Okay, and this one also you extend the line. Okay, until it meets somewhere over here. Okay, and that's where you can draw your image. Okay, this is unfortunate. Not to say unfortunate lah. Okay, this is unfortunate, but I would suggest lah. Okay, I would suggest that especially if you are struggling with this topic lah. Okay, maybe what you can do is when you study, learn to draw the diagrams that we have been drawing so far as a start. Okay, as a start. Okay, draw the convex mirror VUD image. Okay, and then draw this ray diagram. Just practice drawing it until you're used to it. Okay, then focus on this first, and then if you can handle the other drawings, then draw. Yeah, I mean, if you really want to get full marks for this lah. Okay, if you want to get full marks for this, maybe you can focus on the drawings that we have been doing so far. Okay, and commit them to memory. Okay, maybe one day, every day or every time you study physics, just start by drawing first lah. Okay, until it becomes macam, yeah, it becomes like, macam second nature sudah lah. Kau tutup mata pun kau boleh lukis sudah. So, kau banyak kali practice. It's not difficult lah. Okay, let me tell you, it's not difficult. It requires some practice. Okay, it requires some practice. Just to make sure that you're doing it correctly. If you want me to check, just send me a photo of your drawing. Ask me to check, is this correct? You just randomly draw lah. I mean, not to say randomly draw, but focus lah. Okay. So far, the two drawings that we have covered now is this one, number one, and the second one is the convex mirror. The convex mirror drawing also seems to be a popular one. So maybe, if you want to focus on these two drawings first, every day you just draw one time, then hopefully by the time you reach SPM kan, kau tutup mata pun boleh lukis sudah. Okay. Don't be overwhelmed by the rest of the drawings. Okay, focus on what you can do, which is, all these questions that we are focusing on. Okay, so this is the third mark. Okay, mark number 3. I know it's a lot of work for just one mark, but hey, if you can do this, why not? Okay, why not get that one mark? Daripada malas lah saya mau buat, kan rugi satu markah. Okay, question B, diagram 9.2 shows a convex mirror with a radius curvature 4.0. Okay, an object is placed in front of the mirror. Okay, this word, the radius of the curvature, is a very important word because it tells us that this is the letter C. And if you remember from the Melaka question just now, or sorry, this one just now, C is equals to 2 times the focal length, which means that they're not actually telling you the focal length, but they are secara tidak langsung lah memberitahu kamu bahawa the focal length is actually 2 cm. This is a very important thing. Okay, calculate the focal length of the mirror. Okay, F equals to C over 2, which is 4 over 2, which is 2 cm lah. Okay, this is 2 free marks lah. Yang penting kamu faham. Okay, by using the value of F in 9B1, copy and complete the ray diagram in 9.2. Okay, again, this is a convex mirror. Convex mirror, no matter where you put the object, it's always going to be VUD. Okay, and this is the third time we are seeing this drawing. Okay, which kind of tells you a very important thing which I'm not going to say on video lah. Okay, saya tinggalkan kepada kamu lah macam mana kamu mau tafsirkan benda ini. Okay, so I'm not going to draw this here because we've already done this twice. Okay, so go and refer back to the convex mirror. Okay, convex mirror drawing sebelum ini. Okay, and this is a 3-mark question. Okay, curved mirror are always used as a security mirror. Okay, once again, the security mirror question has come up. Okay, in the shop to watch out for shoplifters. You are required to investigate, yada yada. Okay, this one I think is shouldn't be a problem. We've done this in our trial exam, I think. Did we do it in our trial exam? But if not, we've done this quite a number of times now. Okay, but let's take a look. Convex or concave mirror, of course we want convex mirror lah. Okay, sorry. Okay, and convex mirror, the answer for convex mirror is wide field of vision. Okay, bosan sudah. This is the same answer every time. Okay, next, the size of the curved mirror, the same as the diameter question just now. Okay, you want the mirror to be big size. Okay, big size, why? Wide field of vision. Okay, also can lah. Okay, the position of the curved mirror, in the question just now also we saw we want it to be high position. Kita mau cermin di tempat yang tinggi, bukan di lantai. Okay, and then okay, this is a general answer. Okay, which I guess you can say it's physics related. Okay, sorry, the mirror is not obstructed by other objects. I cannot, for the life of me lah, okay, I cannot think about what is the physics concept that I can say for no obstacle. No obstacle, obstruction, not really a physics answer lah. Okay, but I cannot think of any other answer. Apa ini? So that the light is not blocked. No lah, don't need. Okay, characteristic of the coated material. Okay, this is a strong reflector. Definitely lah, strong reflector. Okay, so you can see you can say that the answer for this is to produce better reflection. Wow. Okay, or sharper image. Better reflection means, dia punya image tu tidak kabur-kabur lah. Okay, you get a sharper image lah. Okay, so the best mirror will be you. The best mirror will be you. Okay, so you has a convex mirror, big size mirror, high position, and strong reflector. Okay. Okay. All right. Penang 2023. This is question number 3. Once again, everybody, question number 1 to number 4 are knowledge questions. So be ready for either drawing or calculation or simple explanations. Okay. So, mirror, once again, incoming vehicles on the main road. At this point, I hope that you know that the mirror that we're using is the convex mirror lah. Okay. And what is the advantage? Also the same thing. Okay. Wide field of vision, wide field of view. Okay. Wide angle of view also can. Okay. I think again, as I said before, after a while when you repeat the questions, you find that actually light is not that big of a deal. Unless, okay, unless the question that comes out this year is a real curveball, okay, which we are not anticipating at all, then okay, then something to be afraid of. But generally after a while you'll be like, yeah, these kind of questions only. Okay. Sorry, do we want to draw this again? It's the same thing, okay? It's the same thing as we've been drawing just now. Okay, so I'm just going to right here refer to the convex mirror drawing. Okay, it's a good place to practice, everybody. A good place to practice. Okay, you can use this as a place to practice. Okay, you know what? Let's say, katakanlah, let's say you want to practice drawing Okay, you want to practice drawing, but you don't know how to start. Okay, my suggestion for you is you just draw a straight line first. Okay, and then you put the center Okay, the lens is over here. Okay, so don't worry about the convex mirror, concave mirror Tapi kalau dia convex mirror, if according to this, dia melengkung keluar bahkan. Okay, so you can if you want to, but you don't have to. Okay, you can draw this one. Okay, so this is convex. The most important thing is the F and the C. Okay, so let's say for example on your paper, you tetapkan okay, F adalah 5 cm. So that means C must be 10 cm. Sebab F dan C adalah 2 kali ganda. Okay, so you put 5 cm over here. Okay, here F. Then to 10 cm dari sini, this is the C. Okay, atau 2F. Up to you. Okay, do the same thing on the left hand side. Okay, put the F as 5 cm and then put the 2F or the C, okay, as 10 cm. As long as you know that relationship. Okay, good news about convex is you can put the object anywhere. You can put the object here, you can put the object here, you can put the object here, so you get the same answer. It's always virtual upright image. Okay, but again, the point is, let's say you want to practice this and you don't know where to start. I suggest that you draw this template Okay, draw the axis. Okay, draw the kind of mirror that you want to use. If it is convex, convex. If it's concave, concave. Tetapkan kamu punya F dan 2F and then draw. Okay, if you want to draw a smaller, let's say saya pro sudah tapi saya mau practice yang kecil-kecil okay Set your F as 2 cm. Okay, and then your C will be 4 cm. Then you get a very tiny drawing as long as you got the idea Okay, just to practice the drawing. Okay, saya rasa if you draw one time every day, from now until SPM, by the time you hit SPM kan, tutup mata pun kau boleh lukis sudah. Okay, because it becomes, what is that word the muscle memory will be there Okay, kau sudah lukis kan, tinggal siap. Okay, so a suggestion for you to consider okay, during your study sessions. Okay. Complete the ray diagram. Okay, this is done. State one characteristic. This is standard Okay, virtual upright image. I'm not going to do this one. I think it's a very easy question. So the graph size won't affect the characteristic. No. What will affect the characteristic is where you put the what will affect the characteristic is where you put the object if it is a concave mirror or convex lens. This one is the only one. But if it is a convex mirror or a concave lens, wherever you put the object, or no matter how big your drawing is, you will always get a virtual upright image. Okay, so the most important thing again is that this one must be accurate. You cannot one put the F and the C lah. This one must be accurate. If your F is 2 cm, your C must be 4 cm. For mirror. If your F is 4 cm, your C must be 8 cm. This one must be standard. You cannot, this one you cannot one put. You have to kind of use a ruler. Please, people, make sure you buy ruler. Okay, ruler, protractor, all this mesti masuk dalam peperiksaan ini. Okay, so once you do that, I don't think you can run very far. Okay, good question. All right, let's continue. This is the SBP question. Again, everybody, this is question number 11. We seem to be seeing this trend that the light questions may be appearing in question 11. Maybe, I'm not saying will be, because I'm not a fortune teller, but it seems to be pointed that way. Okay, this lens. Okay, so focal length of lens is determined when the light rays converge after passing through the lens. This is a convex lens. Okay, so what is meant by the focal length? Wow, after so long, we're finally getting this question. Okay, focal length is the distance from the optical center of the lens to its focal point. Okay, this is the focal point. Okay, titik di mana cahaya fokus. This is the focal length. Okay, I cannot tell you how many times students have confused between the focal length and the focal point. Okay, point is titik, length is panjang. Titik bukan sama dengan panjang. The point is not the same as the length. Okay, so focal length is the panjangness, panjangness, okay, of the focal point. Focal point is where the light rays converge. Okay, that is the focal point. So distance from the optical center of the lens. Okay, di sini this is the optical center. Okay, to its focal point, di mana dia berfokus. That's the focal length. Okay, observe diagram 11.1, 11.2. Oh wow, here we go. Compare the thickness, number 1. Compare the angle, number 2. Compare the focal length, number 3. Okay, deduce one conclusion to relate the thickness, the angle, and the focal length. Oh wow. I like this question. Okay, never mind. And then name the physics phenomena involved. So 5 marks over here. 3 things to compare. 1 relationship. 1 name the physics phenomenon. Okay, let's talk about the phenomenon first. Phenomenon is the easiest. Lens is always refraction. Okay, lens, mirror is a reflection. Lens is refraction. Okay, then let's do the thickness. Okay, thickness is quite easily seen. X and Y. X will be bigger than Y lah. Okay, so you can use 11.1, 11.2 or X and Y. Either way also is fine, I think. 11.1 is bigger than 11.2. Okay, thicker lah. Okay, the angle. Okay, look at this angle. Okay, and look at this angle. Okay, it seems that the 11.11 is a bigger angle. If you're not satisfied, use a protractor lah, go ahead. Okay, so the angle with 11.1 is bigger than 11.2. Okay, the focal length. Okay, focal length is here, 5 cm compared to 20 cm. Of course, 11.1 will be smaller than 11.2. Okay. Now, this is a very interesting relationship question because it asks you to give one relationship, but there are 3 things inside the relationship. Okay, so the question that you need to ask is, if this happens, okay, the big question that you need to ask is, what is the manipulated variable, or what are the responding variables? Okay, apa yang menentukan dan apa yang ditentukan? Okay, or what is the cause and what is the effect? So the thickness of the lens, the angle, and the focal length. When you look at this situation, okay, what is most obvious is that the focal length and the angle depends on the thickness of the lens. That means the thickness of the lens is the determining factor. It's not the angle, because the angle is selepas dia melalui the lens. The focal point also is selepas dia melalui the lens. So yang menentukannya, okay, yang mempengaruhi lah, okay, is the thickness of the lens. So in this case, your relationship becomes very special lah. Okay, the bigger the thickness of the lens, okay, then what happens to the angle and what happens to the focal length? Okay, if you take a look, the focal length is in a different direction than the thickness. Manakala, the thickness and the angle is in the same direction. So that means you have to write this twice. The bigger the thickness of the lens, the bigger the angle, theta, and the smaller the focal length. Okay. So this is a very interesting, this is a pretty interesting question lah. At least to me, it's pretty interesting because very rare do we see a relationship question where they ask you to relate three things at once. Okay, the bigger the thickness of the lens, the bigger the angle, theta, and the smaller the focal length. Okay, generally, or at least, usually they will ask you to write two separate sentences. The bigger the thickness, the bigger the angle. And then the bigger the thickness, the smaller the focal length. Okay, but in this question, they're asking you to go ahead and put it all into one, which is the same actually. You're just basically combining the two sentences together. Okay, so don't be so hung up on this lah. It's just, we've been doing this for so long. Okay, it needs just one slight adjustment. Okay, so we learn to be flexible and follow according to rules. Question is, okay, what if, and this happens lah, okay, what if you did not see this, deduce one conclusion, and then you go and write two, you go and write two sentences, okay? I would say that you wouldn't get the mark lah, because you didn't answer the question. The question asked for one conclusion, you go and give two conclusions, and it's only 1 mark. 1 mark means either 1 or 0. There's no half mark in physics. That, oh, kasi kesian lah, bagilah dia setengah markah. Tiada setengah markah ni. It's either 1 or 0. So it's either you write one conclusion or you don't get the mark. Okay, so be careful about this lah. Okay, read the instruction of the questions properly. Kalau dia suruh kamu tick lah. Kalau dia suruh kamu bulat lah. Kalau dia suruh kamu underline lah. Okay, don't simply do whatever you want. Okay. Alright. Diagram 11.3 shows a tool which consists of lens Q used by a gem cutter to examine small gems. Explain how the lens Q can be used as a magnifying glass. So just now we did this by using mirror. We used the Woody method, okay, which is this one. And we talk about the mirror. Okay, use a concave mirror, okay, and then where is the object, and draw the diagram, and then after that, the image is, what is the image form? So let's use this same method, okay, in this case. Okay, gem cutter to examine small gems. Okay, so the first point is what lens? Okay, object where, diagram, and the image what. So the diagram is always the big problem. Let's worry about the diagram later. Let's start from what lens. Okay, so in this case it will be a convex lens lah. Okay, convex lens is used. Okay, point number 2, where do you put the image? In order to magnify, okay, we want to, this one, okay, we want to use as a magnifying glass. There's only one place, the image, but the object. Okay, the object is placed at a distance that is less, okay, then the focal length. Ini mesti dihafal. Okay, kalau magnifying glass, convex lens, unfortunately, convex lens, you have to remember the read lah, read, ris, rim, voom, voom. Okay, you want it to be magnified because magnifying glass. So it's either it's either rim boom boom lah. Okay, but because you want the image to be virtual, okay, so you definitely need the boom boom part. So less than the focal length. Okay, and then point number four. Okay, point number four, the image form is virtual, upright, and magnified. Okay, so place before the focal point. Okay, Isaac, 1 minute. Let me answer this first. So the question is, why are we not using this, the rim? Okay, because the problem with the rim is the rail inverted is the inverted. You want to use a magnifying glass, tapi kau tidak mau dia punya gambar terbalik. Kau mau dia punya gambar, you know, if the pen is like this kan, when you magnify it, okay, the pen is still, the green color part is still on top, bukan di bawah. So we don't want an inverted image. Although it's magnified, but we don't want it inverted. We want it to be upright. Okay, so so okay, coming to Isaac's question okay, this is a great debate lah. Okay, hold on everybody. Let me go back to the drawing first let me see. Okay, don't worry about this I said that less than the focal point remember that the focal length is determined from the center over here. So kalau kau letak less than the focal point, then kalau dia punya focal length adalah 10 cm, then anything less than 10 cm is less lah. That's why I use the word less. Okay, Isaac's question is, can you write place before the focal point? Okay, and so this is a big debate lah, okay, among some teachers lah, because like, okay, for me before is sebelum tau. Sebelum is somewhere in this region. Inilah sebelum. Because before, the word before is like, you know, di belakang lah. Manakala in front of the focal point, you know, is that. But then some people will say, no lah, before focal point, since the zero is there, and then you count backwards, so before is here lah. You know, and then di sini lah semua orang bergaduh-gaduh lah. So, I think Isaac, I don't think that your answer will be wrong. If you write place before the focal point, I think it's not wrong. Okay, because especially if your drawing shows it, if your drawing shows, you know, that this is where you put the object. So even if you write the word before, I don't think people will minus mark from you lah. Okay, but our standard answer, so that everybody, you know, is on the same page, is less than the focal length. Okay, less than the focal length, so that everybody knows, okay, kalau focal length is 10 kan, the object must be less than 10. Okay, and everybody understands less than 10 means 987654321. Before the focal point, after the focal point, any very debatable. But if you write it, if you forget that you're not supposed to write it and you write it anyway and you draw it out, I don't think it's an issue. Okay, I really don't think it's an issue. Okay, let's go for the diagram. Okay, so so this is a standard diagram for this one. Let's draw the axis first. Okay, and then the over here lah. Okay, let's draw this one over here. Okay, let me set my F as suka hati saya lah. Okay, let's say 3 cm lah. Okay, so F is 3 cm and then this is 2F. Okay, and then over here, okay, F is 3 cm around lah. Okay, begitu-gitu saja. Okay, now I'm just cincai drawing lah. Okay, but please make sure it is on. Okay, the object is placed before, sorry, it's less than the focal length. Okay, so I'm going to put the object over here, somewhere over here. Okay, so the first ray diagram will be straight over here and then cuts to F. Okay, and then the second one is towards the center. So this is the center of the lens, so you cut over here. Ayo, my goodness. Let me see if I can draw it straight. Something like that lah. Okay. And obviously on this side, okay, sebelah sini, it's not going to meet. Okay, it's going further and further away. So you have to extend it out to the back. So I'm going to extend the purple and I'm going to extend the green until such a point where they meet. Okay, and the place where they meet is where the object, the image is. Okay, and this is the third mark. Okay, this is the drawing for magnifying glass. So far lah, okay, so far in our discussion, we have been focusing on our main drawing seems to be the convex mirror drawing. This is the most popular question. The second one is the concave mirror drawing. Concave mirror for magnified image, yang makeup mirror tadi. Okay, and now our third drawing is the convex lens for magnifying glass. Okay, so it may be a good idea if you're going to practice drawings, maybe start with these three drawings first. I don't think there's any more drawings after this lah. Okay, maybe start with these three drawings first. Practice it sampai kamu sudah biasa. You know how to draw it by heart. Okay, and then maybe you can focus on the other drawings. But this seems to be the three most famous ones lah. Okay, high chance of this. Okay, of course, the most famous one that we've been seeing so far is the convex mirror. And the reason why I say convex mirror is very popular because it's very easy to mark. It's very easy to mark. It's very easy to remember. Okay, convex mirror lah. All right, let's continue. Okay, 11.4 shows the structure of a basic structure of a smartphone camera. Okay, it is found that the image produced is blurry. Wow, big whoop. Okay, okay, you are required to modify the smartphone camera so that the camera lens is durable, not easily damaged, and can produce a clearer image. Or clearer image pula dia jadinya. Okay, describe and explain the modifications you make to the lens characteristics. 1. Oh, tapi dia tidak. Okay, including the focal length, number 1. Optical density of the lens, number 2. Aperture size, number 3. And this is the worst of it all. Any supplementary tools or features you would add to the lens or the camera aperture. Okay, so this is the problem. This is a problem especially if you are not a photographer and you are like, apa ini perkataan aperture ini? Okay, maybe somebody who is a cameraman, okay, can go and search on the internet or like a simple explanation of what the aperture does lah. Okay, the aperture is this thing, okay, that allows light to enter when it is open. Okay, I think there's a no. Wait, that's shutter. Is it shutter or aperture? See, obviously I'm not a photographer, so I'm like the most blur person on this lah. But the idea of the aperture, okay, the idea of the aperture is if you have a bigger aperture, you can have more light to enter. There's lebih banyak ruang lah. Okay, I think this is an indicator of, this is an indicator of the aperture lah. Okay, so the aperture allows the light to enter. So if you have a bigger aperture and also if your shutter is, if your shutter is open for a long time, okay, more light can enter lah. If you have a smaller aperture, then less light can enter. So generally as photographers, if you have please correct me if I'm wrong, if you're a photographer, correct me if I'm wrong, if you have a smaller aperture, then, you have that, apa tu dalam telefon kita panggil apa, the bokeh effect, where only the thing in front of you is in focus, everything else is out of focus. If you have a bigger aperture, then you can have more things in focus lah. Okay, more light can enter. So the idea of this is, the problem with this is the clearer image part. Okay, and I think the reason why this question was a little bit funny is, what is your idea of a clearer image? Is it because kalau dia punya aperture kecil, okay, if so far nobody is correcting me, so I'm very scared that I'm doing this wrong. Okay, if the aperture is very small, then the object in front of you is in focus. Everything else is not in focus. So that is a clear image. Is that not a clear image? A clear image of the person in front of you. Okay. Don't worry, sir. You're correct. Okay, thank you. But if the aperture is big, okay, more things are in focus. Okay, so you can see more, but that is also a clear image. Okay, so the question is this: what is a clearer image? Very, very subjective. You know, uh, maybe for those of you who use like for your camera phones, I think smaller aperture is, for example, portrait mode lah. Portrait mode usually use smaller aperture because you only want to focus on that object. Whereas the normal photo has a bigger aperture lah. Okay, so more light. But the idea is when you have a bigger size aperture, you can have more light to enter. Okay, itu saja yang penting. Okay, and it doesn't help that dalam bahasa Melayu, aperture is bukaan. Okay, bukaan sajalah. Okay, so yeah, either way. So there's all these things lah. Okay, supplementary tools, but let's focus on this first. So this is the answer lah. Okay, focal length definitely has to be bigger. Okay, longer focal length, bigger focal length. Okay, so that you can get a bigger image. Okay, or a bigger magnification. Okay, which we saw in the comparison question just now lah. Okay, the optical density of the lens is high. Okay, we want a lens to be higher optical density. Okay, so that, okay, and this is where everybody is going to, this is where everybody's going to decide. Okay, shorter focal length. Okay, or thinner lens. Okay, so this seems to be in opposition. Okay, on one hand, you want the focal length to be big. On the other hand, you want the focal length to be not too big. Because if it is too big, then you get a thicker lens. If it's thicker lens, then it's a big problem. You cannot have a smartphone camera. Okay, so yeah. Okay, shorter focal length, then you will get a thinner smartphone. Okay, so once again, everybody, the balance between the two is very important. How do you have a long focal length lens, but still, so that it is not too thick? Okay, the thinner lens lah. Okay, so yeah, technology these days is quite amazing lah. Okay, we can fit a lot into one small phone. On the other hand, the phones are getting bigger and bigger lah than when we first started. Okay, the size of the camera aperture, okay, definitely is big. Okay, big size camera aperture. Okay, so that this is the standard answer lah. Okay, more light can enter. Okay, so we have covered this one. Focal length is done, optical density is done, aperture size is done. So now comes to the rest of the stuff that you want to add to the lens or the camera aperture. So one of the suggested answers was to increase, okay, the number of lenses. Okay, when you increase the number of lenses, then you can either have a bigger image or bigger magnification. Okay, that's one possibility lah. Okay, another one is to add a transparent cover. Okay, for the lens. Okay, nowadays at the back of this one, you put a cover over there to kind of protect this one lah. Okay, so to protect the lens. Sorry. The reason for this is to protect the lens from dust or scratches. Hold on. Okay. One last one. This one is a bit weird lah, but can lah. Okay, low oxidation rate of the lens. What's the difference between multiple lenses and one big lens? Um, well, I guess if you have one big lens, you can put it into a DSLR lah. But having multiple lenses working on one image is more practical for a smartphone, possibly. Like if you put one big lens on a smartphone, yeah, I guess maybe the question is why did nobody think of that? I guess having one big lens may not be able to provide you with the magnification that you need, because everybody now is chasing for 20, 50, and I heard that there's going to be a phone that's going to be like 100 times zoom. So maybe having multiple lenses will help with the zooming effect. If you have just one big lens, there's only so much you can zoom with just one lens. But having multiple lenses work on the same image and trying to zoom in at the same time, of course with the help of digital effects, because digital zoom and optical zoom are two different things. So maybe having a multiple lenses is a more practical idea for a smartphone. And despite what you may think, people seem to think that having 3 dots at the back of your phone, or in some cases 4, okay, is better looking than having one big dot, one big lens at the back of your phone. So there's an aesthetic feel to it, and I think practically you can do more with multiple lenses than with one big lens, which is probably why only DSLRs work with one big lens. But we cannot fit a DSLR lens into a smartphone unless you want a smartphone to be a DSLR. Okay, low oxidation rate is to avoid. Usually oxidation rate we talk about rusting, right? Okay, but in terms of this rusty, well, lens is not metal okay, so they usually don't rust. So to avoid blurred lenses. Okay. Oxidation in a lens chips away the lens, doesn't make it rust. Rust is an effect on the metal itself but on the lens, because the lens is not made of metal, so when it oxidizes dia akan jadi macam not smooth anymore. Okay, it becomes a very rough lens. So we usually say that the images okay, are blurred. Avoid blurred image. Okay, for oxidation rate So this is something new I also only discovered this when I was looking through the marking scheme. It's like, oh, okay, interesting. They're using oxidation rate for lenses, and then I realized that okay, you cannot talk about oxidation rate for lenses and then rust, because rust is for metal. For lenses is to avoid blurred image. So nanti dia akan terkikis All right. Is this the last one? Oh, we still got one more. Oh no, 2 more. Okay, sorry. All right, let's hang in there, everybody. 2 more, and we're going to be done. Okay, 3.1 shows the apparatus used to determine the relationship between the object distance and the image distance. Okay, the results as shown as this. Wow, this is a good question. Okay, convex lens is a converging lens. Okay, diverging is concave lens. Okay, and remember that mirror and lens are opposite. Okay, converging is convex lens as concave mirror. Okay, also concave mirror. Diverging is convex mirror. Okay, the word converging, diverging okay, menumpu mencapa. Okay, distance between the bulb and the lens is 30 centimeters. Okay, the bulb and the lens so U is 30 cm. Okay, so U is 30 cm. Focal length for the convex lens is 20 cm. Okay, this is F. So calculate the image distance. This is the formula. Wow, this is the first time we're using formula. 1 over U plus 1 over V. No need to change anything. Okay, so 1 over 20 equals to 1 over 30 plus 1 over V. Switch it around, everything, you'll get V equals to 60 cm. Okay, don't worry about this lah. Okay, just a side note. If you're going to use this formula, and I really don't know whether I put this here or not. Oh, I did. Okay, if you're going to use this formula, be aware that when you use this formula, okay, the F and the V may have positive or negative value. So very important. Okay, if we are using a convex lens, like in this case, we're using a convex lens, the F is positive. Okay, tapi kalau soalan dia minta concave lens, the F is negative. Okay, and is not given to you. Sorry, I mean this fact, okay, you have to remember, it's not given to you. They will not write there, the focal length of the concave lens is negative 20 cm. No, they won't. You have to put in the negative yourself. Okay, so it's very important. Same thing, if your V is a positive value, then the image is a real image. If you find that the V is a negative value, jangan panic. Negative value for V just means that it is a virtual image. Okay, we covered this very briefly at the beginning of this year. Okay, so so I just want to recap this lah. Okay, if the image is virtual, then the image distance is negative. Yeah, isn't that what I said? If the image is virtual, then the image distance is negative. The V value will be negative. Okay, but in this case, everything is positive, so don't worry about it lah. Okay, just to use the formula only. Okay, based on diagram 3.2, what is the value of Q? Okay, let's take a look at this. This is 1 over F equals to 1 over U plus 1 over V. Okay, it's our this one. But our y-axis is 1 over V. So let me switch this around. I'll get 1 over V equals to 1 over U minus 1 over F. Oh, sorry, did I do this wrongly? Sorry, 1 over F minus 1 over U. Okay, so this is our y-axis, this is our x-axis. Okay, and so 1 over F over here is our y-intercept. Okay, so our y-intercept is Q. Okay, our y-intercept is Q, which means that 1 over F equals to Q. And so we know that F, according to this question, is 20 cm. So 1 over 20 equals to Q. Okay, so Q is 1 over 20. Just leave it as it is. Okay, don't worry about the value 0.0 this one. Okay, so how do you explain your answer in this? Okay, so you compare. Okay, compare 1 over V equals to 1 over U minus 1 over F to the graph. The value of the y-intercept is Q equals to 1 over U. 1 over F. Sorry, did I do this right? Oh, 1 over F. 1 over F. 1 over U minus 1 over F. Yeah, my goodness. 1 over F minus 1 over U. 1 over F. Okay, it's 1 mark. It's 1 mark. Okay, this is a slightly difficult question lah. Okay, rarely, jarang ni kita tengok. Okay, which is good that we covered this in a little while. All right, one last question to go. One last question to go, and then we'll call it a day. The Terengganu paper, thankfully, is question number 2, so it won't take us very long to finish lah. Okay, diagram 2.1 shows this, and then of course, This is a phenomenon due to the refraction of light. Okay. So what is the meaning of the refraction of light? The refraction of light is a change in velocity. Yeah. Okay, change in velocity. Or actually, you know what? Let's keep it the same as the wave lah. Okay, the bending of light waves. Bending of light waves after passing through mediums with different optical densities. Okay, so the only difference between refraction of light and refraction of wave is the word optical. Okay, so make sure that if it is refraction of light, kamu letak perkataan optical. Kalau dia refraction of wave, okay, then you just say bending of waves. Okay, bending of waves after passing through mediums with different densities. Enough. Okay, so we keep the definition same, just like color light. Make sure that you put the words that have to do with light on this lah. Okay, explain how phenomenon in diagram 2.1 occurs. This one actually can be found. Let me see. Hold on. Oh, okay. Yeah. Bah, never mind. Okay, so in this case, this is a 2-mark question. So the light travels or light propagates from this one is the receding from a high optical density medium, which is water, to a low optical density medium, which is air. Okay, and then the second one is where does it travel to lah? Okay, it travels, the light refracts away from normal line. Okay, 2 marks only because it's only 2 points. Okay, remember the thing that I showed you just now, which was much earlier, this one. When you want to discuss refraction, just talk about these 2 points. Light travel dari mana ke mana, and then the direction of refraction, whether it's away or towards the normal line. Okay, so we're still holding on to these tips right at the very end. Okay, point number 1, light travel dari mana ke mana. Okay, water is high density, and then air is low density, low optical density lah. Okay, and then after that, the light refracts away from the normal line. Okay, the 2 marks over there. All right, let's finish this with a drawing. Okay, now remember for a refraction diagram, okay, teacher, I thought less dense to more dense is towards. Yeah, but we're going from more dense to less dense because your eye is over here. So the light has to travel, from the water to the air. Oh, sorry. Yeah, away from the water to the air. Has to go away from the distance. The light doesn't come from your eyes. Light enters our eyes. Okay, if light exits our eyes, then we're all like Cyclops in X-Men. Okay, we're not. Light travels into our eyes. So when you think about that, if it travels into our eyes, means it must come from the air. So what is before the air has to be water lah. Okay, this is another tip. If you're drawing a ray diagram for refraction, okay, just remember that from the image, okay, from the image to the observer, okay, wherever the observer is a straight line. Okay, from the object to the observer is a bent line. So my tip for you is, you draw a straight line from the image to the observer like this. Okay, this is a straight line. Okay, and then this one. But the only thing is, yang di belakang sini kasih putus-putus. Okay, so let me draw this again. This is one, and then after that, putus-putus macam tu. Okay, straight line. And then the other one is a bent line. Begitu saja. That's all. Okay, but the only one is these two, okay, must be straight like this. Hanya ini saja. This is the only one that is dotted. Okay, be very careful because the image is a virtual image lah. Okay, and that's how you would draw the position of the image observed by the fish. Remember, observer to image is a straight line, except that the second half, okay, is dotted, 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 dotted. From the observer to the object is a bent line, tapi seluruhnya adalah nyata. Okay, it's a straight line that cannot be changed. That cannot be dotted. Sorry. Okay, I think that's it. Yes, that's it. That's the rest. That's our class for today. Sir must he be connected to the eyes? Sorry, did I say sir? Teacher must he be connected to the eyes? Yeah. Yeah, sorry, this is a very bad drawing. I connect it to the mouth pula kan. Yeah, must be connected to the eyes. Sorry, it should be from the eyes. From the eyes, not from the mouth. Please correct my horrendous drawing. Okay, good question. Yeah, it must be connected to the eyes. Okay, so our next session is on the 26th, okay, and we're going to do forces and motion 2, okay, forces and motion 2. So if you can, okay, spend some time to answer the questions in there, and then come in and get the answers. If not, then it's okay. We can always do a study session on the 26th. Okay, next week's class yang banyak sikit lah, 26, 28, and then 30. So let's be aware of that lah. Okay, so that we can finish all these 5 topics before our holidays end.